Okay, so this is our notes on solving for an angle with trig, and I intend you to put this in the same spot where we started the previous trig notes. So it was a little foldable we made in class. I put what it said on the outside right here just to show you like what section I'm in, and then we'll be writing on the inside of it. So I also had some requests for background music, so during this video we'll be listening to Solange. Alright, so we're going to start in the sine section, and I have the equation that we are already using where it says sine of theta is opposite over hypotenuse. And sometimes we're not going to know our angle. Our angle is theta, and sometimes we're going to want to be solving for that. So there's actually a way to undo the sine function. Just like multiplication and division are inverse operations, there's an inverse operation for sine. And what it's called is sine inverse. And how we note it is sine with a -1 as the exponent. So this next line here, all I've done is I've taken the equation that I started with, sine of theta equals opposite over hypotenuse. And I want to get theta by itself right here, and I need to get rid of sine in order to do that. So all I've done is sine inverse both sides. And we don't have to really know how sine inverse works other than the fact that it undoes sine. It's the inverse operation for sine. So when I sine inverse both sides, on the left-hand side I get just theta. So if we're trying to find out what our angle is, remember theta is the variable that represents it. I'm trying to get that variable by itself. And then on the other side, I would have sine inverse of my opposite over hypotenuse ratio. In a couple minutes, we're going to see what that looks like exactly in an example. But for now, we're just going to do this to cosine and tangent as well. So just like sine has a sine inverse, cosine also has a cosine inverse. So I've taken this cosine of theta equals adjacent over hypotenuse equation, and I've done the same thing. I have cosine inverse both sides. So what happens when we cosine inverse both sides is our cosines cancel on the left side, and we're left with just theta. And on the other side, we'll be taking the cosine inverse of our ratio, which is adjacent over hypotenuse. So theta equals cosine inverse of adjacent over hypotenuse. We have one last one to do, and we're going to do it to the tangent function. So when I take tangent of theta equals opposite over adjacent, and I'm undoing tangent, I'm going to do the tangent inverse. Where is it? So I've taken tangent inverse of tangent of theta, and then I've also taken tangent inverse of opposite over adjacent. And when I tangent inverse this side, just like the others, we're going to be left with just theta. And on the other side, we have tangent inverse of opposite over adjacent. I'm going to show you how this is going to work in an example, but just make sure that you have these parts written down in your foldable, and then we can move on. Okay, so these are solving for an angle examples. So we're going to be solving for an angle. Sometimes we might have a question mark here or a variable. I've put theta there. So normally we had like an x as a side length, and that was our unknown. Well, now our unknown is the angle, and we know 2 of the side lengths. So when we set up our ratio, we're not going to have x in our ratio. We're going to know both of the values. So after we label this triangle here, which I will do right now, after we label this triangle, this is our opposite side, and this is our adjacent side, so we're going to be using tangent. So we start with the equation just like we have been doing other times. Tangent of theta equals opposite over adjacent. And just like we have done in the past, when we write out that equation, then we start plugging in what we know. So in this case, we do not know theta. We're going to leave that as a variable, but we do know the opposite side, which is 15, and we know the adjacent side, which is 20. So then I'm going to try to or I'm going to isolate theta. I want to get theta by itself. That's the angle. So just like I showed you in the foldable, now we tangent inverse both sides because tangent inverse and tangent undo each other. So what happens here is we can basically cross these off. I'm just left with theta, and on the other side I'm taking the tangent inverse of 15 over 20. Okay, so to continue on, theta is equal to the tangent inverse of 15 over 20. And basically we're going to try to take that ratio and trace it back to the angle that it goes with. So in our trig table, we know everything is in decimal form. So what I'm doing next is I'm going to take 15 over 20, just put it in the calculator and get the decimal version. So next I've rewritten this equation, but instead of 15 over 20, I have 0.75. And now this is where you need to pull out your table. So we're going to look in the tangent column of the table, and we're going to find where the decimal is closest to 0.75, and then I'm going to look over at the angle that goes with it. So I've just taken a little snippet of a table. It doesn't, it doesn't have the same font as your table, but it is the same table. So in the third column is tangent, and what I've found to be closest to 0.75 is 0.7536. And then we look over at the angle that goes with that, and our angle is 37. So our final answer here is theta equals 37 degrees. And that is it. So I know it seems kind of funny at first. We're going to practice it in class, and we also have one more example in this video. Really just introducing this concept of an inverse trig function, and then we're trying to take our ratio and trace it back to the angle that goes with it. Okay, so example 2. So here's our triangle. Just like last time, we're going to want to label it to figure out what ratio we would use. So when I look across from the angle, that's opposite, and then this one is our hypotenuse. So opposite and hypotenuse is sine. So I take the sine equation just like I've done in every other problem. Sine of theta is opposite over hypotenuse, and then I start plugging in what I know. So I do not know my theta. That stays as a variable, but I do know my opposite is 22. And my hypotenuse is 37. So now I'm going to isolate my theta by doing sine inverse to both sides. I want to undo this sign right here. So I sine inverse both sides. Ignore that it turned it into a big circle for some reason, but that's sine inverse of sine of theta, and then sine inverse of 22 over 37. And oops, I'm a little bit over my previous table there, but now I'm taking just theta equals sine inverse of 22 over 37. And just like I did in the last problem, I'm going to find the decimal version of 22 over 37. So I plugged that into my calculator, and I got 0.5945. So I'm going to now be looking in the sine column and trying to find the decimal that's closest to 0.945. So you got to kind of scroll through the sine column, and what we find is right here, this 0.5878 is the closest I can get to 0.5945, and I look over at what angle goes with it, and it's 36. So our angle, our theta, is 36. 36 degrees. Okay, so make sure you have complete notes, and then we'll do some practice in class. If you had any questions on this, I really strongly encourage you to go back to that part, maybe listen again, jot down a question, think of something specifically that you didn't understand so I can help you out on it. We really want to be engaged when we're doing these and coming up with our own questions so we can get clarification in class. So I will see you in class.